Hi class, this is Chapter 1, Introduction to Nutrition. Now, when we hear the word nutrition, it's pretty easy to think first about food choices, like what we had for breakfast, whether a certain food is healthy, or maybe the latest nutrition claim we saw online, because we see a lot of them all the time. But in this course, we're going to look at nutrition from a scientific perspective. So nutrition science asks what substances are in food, what happens to those things once they enter the body, and how they affect normal body function and health over time. So if you eat a bowl of oatmeal for breakfast, we aren't only interested in whether oatmeal is a healthy choice. We can ask what nutrients it contains, how its carbohydrate is digested, what happens to its fiber, and how those nutrients are absorbed and how the body ultimately uses them. So Chapter 1 gives us the vocabulary and basic framework that we need before we dig into those processes in more detail. So we'll start with the nutrients themselves, look at food as a source of energy, consider the relationship between diet and health, and finish with some principles that will help us evaluate nutrition information more scientifically. Now, this might be a review for you, and that's perfectly fine, but this does build the foundation for the class. So the human body, follow along on this slide, requires 6 major classes of nutrients: carbohydrates, lipids or fats, proteins, vitamins, minerals, and water. You're going to see these 6 categories throughout the semester, so it's worth getting comfortable with them now. Now, they don't all do the same thing. Carbs and fats are important sources of energy. Protein can provide energy too, but it also supplies amino acids that the body uses to build and maintain proteins in tissues. Now, something I want you to remember is that vitamins and minerals do not provide calories, but they participate in many processes that keep the body functioning normally. Now, water doesn't provide calories either, but we obviously can't function without it. So we can also classify the nutrients chemically. So carbohydrates, lipids, proteins, and vitamins are organic compounds because they contain carbon. Minerals and water are inorganic. You'll also hear the term essential nutrient. And an essential nutrient is one that we must obtain from the diet because the body can't make enough of it to meet its needs. For example, vitamin C. Humans can't synthesize the vitamin C that we need, so foods like citrus fruits, strawberries, and even peppers, we have to rely on those things to supply it. And as we move through this semester, we'll take these broad categories apart and kind of look at what individual nutrients actually do in the body. So take a look at this slide. Another way to organize nutrients is by how much of them that the body actually needs. Now, carbohydrates, fat, and protein are called macronutrients, or maybe you hear people say macros, because we generally need them in relatively large amounts, usually measured in grams. So think about a food label. You might see 25 grams of carbohydrate or 10 grams of protein in a serving. Vitamins and minerals are micronutrients because we need them in much smaller amounts. Their quantities may be listed in milligrams or even micrograms, so much, much smaller. But smaller amounts don't always mean smaller importance. I want you to remember that. Iron is a really good example of this. We need far less iron than we do, say, carbohydrates, but iron's still essential. It's part of our hemoglobin, which helps transport oxygen in the blood. So a micronutrient can be needed in a tiny quantity and still have an extremely important physiological role. Now, water is a little bit different. We need it in large amounts, but it doesn't provide any energy. It serves as basically a solvent. It helps transport substances in our bodies, participates in various chemical reactions, helps regulate our body temperature. Now, this chapter will also introduce phytochemicals. These are compounds produced by plants that may have biological effects, but aren't classified as essential nutrients. You'll find them in things like fruits, vegetables, whole grains, beans, herbs, and other plant foods. And a substance can potentially influence health without technically being a nutrient. So that's important to remember. Now let's look at food as fuel. One of the most measurable things that food provides is energy. And in nutrition science, we usually express food energy in kilocalories, the calories you see on a food label, for instance. Scientists can actually measure that energy contained in food using direct calorimetry, including a device called a bomb calorimeter. Now, you probably won't use that unless you were something like a food science major. So if you want to learn more about bomb calorimetry, you can look that up. Now, in everyday nutrition, though, we can estimate energy based on the macronutrients in a food. Carbs provide about 4 kilocalories per gram, and you can see that on the slide. Protein provides 4 as well, and fat is different. It provides 9. Now, alcohol provides about 7 kilocalories per gram, but it's not considered a nutrient because we don't need that. So here's a simple way to see why those numbers matter. A tablespoon of olive oil is almost entirely fat. So a relatively small amount provides quite a bit of energy. Now, a slice of bread contains mostly carbohydrate and usually provides fewer calories by weight. But that doesn't mean olive oil is unhealthy and bread is healthy. It simply reflects the fact that fat contains more than twice as much energy per gram as carbs or protein. So later we'll go beyond these numbers and look at how the body digests these various nutrients and converts their stored chemical energy into forms that the cells can actually use. So let's take a look at this slide. Does diet matter? Absolutely. But this is where I want us to start being careful with our scientific language. So dietary patterns are associated with the risk of several chronic diseases, but chronic disease is rarely caused by one food or one nutrient alone. Health develops from a much more complicated interaction among genetics, your behaviors, the environment that you grow up in, access to health care, your physical activity, and many other factors. So think about something like cardiovascular disease. Someone might have a family history that increases their risk. For instance, I do. My family has an increased risk of cardiovascular disease. They may also have high blood pressure. Maybe they smoke. They might be physically inactive or have dietary patterns that contribute additional risk. Now, those factors don't all carry the same weight. And having a risk factor doesn't mean that you'll develop a disease. But this is why the term risk factor is useful. It describes something associated with an increased likelihood of a particular outcome. It does not mean the outcome is inevitable, however. And this is why we need to be cautious when we see headlines such as, "This food causes cancer," or "Eat this every day to prevent heart disease." Nutrition science is usually much more nuanced. We want to know what was studied, in whom those things were studied, for how long, and whether the evidence shows an association or actually supports a cause and effect relationship. Now, I always find this topic really fascinating. Why do we eat what we eat? Because what you eat could be completely different from what I eat. Now, if humans selected food based only on nutrient requirements, then eating would be pretty simple, right? We would identify what our bodies needed and eat according to that. But that's not how people actually eat. Now, imagine you walk past a bakery and you smell bread coming out of the oven. You may suddenly want something to eat, even if you weren't thinking about food 5 minutes earlier. Now, that's a sensory influence. Or think maybe about foods that are part of holidays or even family traditions. You may choose them because of what they mean to you, not because you evaluated their vitamin and mineral content first. Hunger and thirst, taste, smell, appearance, your culture, cultural background, family experiences, even your religion, your mood, stress, income. There's so many of these. Location, convenience, food availability, even packaging. in marketing can all influence food choice. I don't know about you, but if I see a really flashy or pretty package, I may pick that one actually over one that's healthier just because I like the way that it looks. So this matters scientifically because nutrition research involves human behavior. And researchers can tell someone what to eat, but people live in real environments where dozens of other factors influence those choices. So that's one reason studying human nutrition can be much more complicated, really, than it first appears. So something that I want you to look at, this is in your book, are two terms that are especially useful when comparing foods. This is nutrient density and energy density. And they sound pretty similar that, in fact, some students will mix them up because they do sound so similar, or they'll just get confused. But nutrient density is about what nutritional value comes along with the calories in a food. So think about, let's think about a cup of strawberries. You get carbohydrate and calories, but you also get vitamin C, fiber, water, and other compounds. Foods like vegetables, fruits, beans, whole grains, low-fat dairy foods, eggs, and some minimally processed foods can provide substantial amounts of beneficial nutrients relative to their calories. So now let's compare the strawberries with a sugar-sweetened soft drink. It provides energy primarily from added sugar, but generally contributes relatively few vitamins, minerals, fiber, or other key nutrients. That illustrates the chapter's idea of empty calories. So, energy density asks a different question. How many calories are packed into a given weight of food? A pretty useful example is grapes and raisins. They come from the same fruit, right? But raisins have had much of their water removed. And because the calories are concentrated into a smaller weight of food, raisins are more energy dense than fresh grapes. Foods higher in fat also tend to be more energy dense because fat provides that 9 kilocalories per gram. And nuts and peanut butter are good examples. They're energy dense, but they also provide nutrients. So energy dense does not automatically mean that it's nutritionally poor. So keep the two questions separate. Nutrient density asks, what nutrients am I getting for these calories? Energy density asks, how many calories are packed into this amount of food? So those are different characteristics. Now, once we understand that foods contain different mixtures of nutrients, they don't just contain one nutrient, the ideas of variety, moderation, and balance make a lot more sense. And you'll want to make sure that you understand each of these. Variety matters because no single food provides every nutrient that we need in ideal amounts. So an orange, for instance, might be a great source of vitamin C, but it's not going to supply everything that our bodies need. Now, milk can provide calcium and protein, but it doesn't replace vegetables, fruits, grains, or other foods. So eating a variety of foods helps us obtain a broader range of nutrients. Now, moderation is about amount. Even foods that provide valuable nutrients don't need to be consumed without limit. Peanut butter, for example, provides protein, fat, vitamins, and minerals, but it's also pretty energy dense. So portion size still matters. Now, balance includes the relationship between energy intake and energy expenditure over time. So the bigger message is that nutritional adequacy is not created by one meal or one perfect food. It develops from the pattern of foods and beverages consumed over time. That's a much more useful way to think about diet than trying to classify every individual food as simply good or bad. So this chapter also introduces an important principle. For healthy people, food's generally the most reliable and economical way to obtain the nutrients and beneficial phytochemicals that your body needs, especially when your diet includes a variety of whole and minimally processed foods. Think about that orange again. You aren't getting only vitamin C, you're getting water, carbs, fiber, provides a lot of potassium, vitamin C, and a mixture of plant compounds, all packaged together in that one food. Now, that doesn't mean supplements never have a role, okay? Some people may need supplemental nutrients because their needs can't be met adequately through food alone. Supplements can contain vitamins, minerals, herbs, and other plant products and amino acids. Now, the important point here is that more is not automatically better. If someone needs a certain amount of a nutrient, taking 10 or 20 times that amount doesn't mean the nutrient will work 10 or 20 times better. So a mega dose is an amount of a vitamin or mineral that greatly exceeds the recommended amount, and nutrients have ranges of safe intake. So keep that in mind. The idea of dose is important throughout nutrition science. Water is essential. Iron is essential. Vitamin A is essential, but essential means that the body needs an appropriate amount. It does not mean unlimited intake is beneficial. You can die from drinking too much water, so keep that in mind. Now, I want to end chapter 1 with what I think is one of the most important ideas for the entire course, that nutrition is a dynamic science, meaning it is evolving, it is changing all of the time. Now, you've probably experienced this yourself. One day you see a headline telling you a food is wonderful for you, and then another day you see a headline that questions that. That can make nutrition seem pretty confusing, but often the problem is that a single study is being presented as if it were the final answer. And we know science doesn't usually work that way. Researchers ask a question, they collect data, they analyze that data and the results. They'll publish their findings in peer-reviewed journals. And then other scientists evaluate, repeat, challenge, or even build on that work. So over time, a larger body of evidence develops on the topic. Now, human nutrition adds another layer of difficulty. So suppose researchers want to study whether a particular dietary pattern is associated with heart disease over 20 years. They can't control every meal those participants eat for 2 decades. People also differ in their genetics, their activities, whether or not they smoke, what kind of medications they take, how much money they make, how much sleep they get, even stress, and many other factors can influence health. So when nutrition recommendations change, it doesn't necessarily mean scientists had no idea what they were doing before. So sometimes it means better evidence has allowed the scientific understanding to become a bit more precise. Now, as we go through our course, I want you to get into the habit of asking a few questions whenever you encounter a nutrition claim, because you're going to see them all the time. What exactly was studied? What was measured? Who was studied? Does the evidence show an association, or does it support causation, for instance? And does one study agree with a larger body of evidence? So if you can begin thinking that way, then you're doing much more than memorizing nutrition facts. You're learning how to think like a nutrition scientist. And that's the real foundation that I want this chapter to establish. Now that completes our information here. If you have any questions at all on chapter 1, anything that you've seen throughout this week, just drop me an email. We can talk about it. I'd be happy to answer any questions. I hope you have a great week.